Question 1. We need to work out the length of arc AB, so that's the length of this part of the circumference. So the approach for this is, imagine you are working out the circumference of the whole circle. The circumference is pi times diameter. That would be pi times the diameter of the whole circle, which would be 14, 2 lots of 7. But we want 40 degrees worth of that circle. So what proportion of the circle is that? That's 40 degrees out of 360 degrees worth. So we do 40 over 360 to get the proportion, then we multiply that by pi times 14, which is working out the circumference of the whole of the circle, giving us this, which to 3 significant figures is 4.89. Question 2, work out the length of the arc ABC. So this is this length all the way around here, the bit that I've just shaded in yellow. So very similar to the question beforehand, it's a proportion of the circumference. The circumference of the circle will be pi times the diameter, pi times 8. We want 260 degrees worth, so 260 out of 360 multiplied by the circumference of the circle, giving us this, which is 18.2 to 3 significant figures. Question 3. So part A, we need to construct the perpendicular bisector of the line. So that line is perpendicular, meaning it's at 90 degrees, and bisector means it's exactly halfway along. So to do this, we get out our compass and we go and put the pin here at A, and we get a length to about here, so over half but not quite the full length, and we do this big arc here in blue. And then without changing the length of between the pin and the pencil, do a second arc with the pin here. That's the second arc here. And then our final answer is the straight line that goes through where these two arcs intersect. So my final answer is the red line. The blue lines are my construction lines. Now for part B, I've got to work out the angle bisector. Question 4. Now we're being asked to calculate the mass of this prism. Now, density equals mass over volume, so multiplying both sides by volume, we see that the mass equals the density times the volume, and we're given that the density is 6.6. So we need to work out the volume of this prism. Now, how do you work out the volume of a prism? Well, it's step 1, you work out the area of the cross section, the area of the end bit, which on this occasion is a triangle. How do you work out the area of this triangle here? Is half times base times height, half times 5 times 12. And then once we've worked out the area of the cross section, you multiply this by the depth of the prism, which is 15. So half times 5 times 12 is the area of the triangle, multiplied by 15 gives me 450. Question 5. So I need to work out the volume of this prism. Step 1, I need to work out the area of the end bit. Now this is a compound shape, so I'm just broken it up into 3 simple shapes, a couple of rectangles and a triangle. So the area of this rectangle here is 3 times 8, which is 24. This rectangle here has got a base of 5, because that's 8, take away the 3, which is 5, and a height of 3, so that area is 3 times 5 is 15. Now this triangle here has got sides of 5, so half times base times height, half times 5 times 5 is 12.5. So my combined surface area of the cross section is 51.5 when I add these 3 together, and then I take this area of the cross section, multiply by the prism's depth, which is 12, to get 618 centimeters cubed. Question 6. Step 1, I need to work out the area of the cross section, which comprises a couple of rectangles. This first rectangle is 5 times 7, which is 35. The base of this second rectangle is 6, because that's 11, take away the 5, which is 6. 6 fours are 24. So my combined surface area of the cross section is 35 add 24, which is 59. Then step 2, multiply this by the depth of the prism. 59 times 20 gives me 1180. Question 7. Now, a couple of different approaches here to work out the area of the cross section. You could break it down into 3 rectangles rather. That would be absolutely fine, and just add them together. But what I've chosen to do is to work out the area of the whole rectangle, which is 7 times 5, which is 35, and take away from that this bit that's sort of been cut out, this 2 times 3 bit, which is 6. So a quicker way to work out the area of this cross section is 35 take away 6, which is 29, and then step 2, multiply this by the depth of the prism. 29 times 9 is 261 centimeters cubed. Question 8. So let's start off by just working out the volume of the original large tin. So volume of a prism is area of the cross section, which is a circle here, pi r squared, multiplied by the height of the cylinder. So pi r squared h. So pi times 6.5 squared times an h of 11.5 gives me a volume of the large tin of 3887 over 8 pi. Now my new tin is going to have the same volume but a different radius of 5.8, and I've been asked to work out the height of the new tin. So the volume is still 3887 over 8 pi, and that equals pi times my new radius of 5.8 squared times my unknown height. Now I can cancel out those pi's, and then what I've done, I've just divided both sides by 5.8 squared to work out h. So to get this, I did 3,887 over 8. Question 9. So, the seawater, density equals mass over volume. Now the seawater, we've got 1 litre of seawater having a mass of 1030 grams. So the mass is 1030, and then you need to appreciate that 1 litre is the same as 1,000 centimetres cubed. So the 1 litre is my 1,000 here. 1030 divided by 1,000 gives me a density of seawater of 1.03. Now let's think about the wood. The volume of the wood in centimetres cubed is 3 times 20 times 120, which is 7,200. Now the mass of the wood in grams multiplying by 1,000 is 8,000 grams. So the density of my wood is mass over volume is 8,000 divided by 7,200, which is 1 1/9. Now the density of the wood is greater than the density of the seawater, so the wood would sink. Question 10. So, first thing to have a look at is the total mass of my two alloys together. So, I've mixed 150 grams of A and 300 grams of B. So my total mass is 300 grams. Now, to work out the volume of each of the metals, I've done the side working over here with density equaling mass over volume. So my volume of A, which equals mass divided by density, when you rearrange this, so my volume of metal A is the mass of 150 divided by the density of 19.3, which is 7.772. And my volume of B is a mass of 150 divided by the density of B of 8.9, which is 16.853. So my combined volume of the two, when I add the two volumes together, is 24.625 ... So my overall density equals my overall mass divided by my overall volume, 300 divided by 24.625, which is 12.18, 12.2 to 1 decimal place. Question 11. So the volume overall is 15 add 250, which is 265. Now density equals mass over volume. Multiply both sides by volume, you get mass equaling density times volume. So the mass of my orange concentrate is its density of 1.2 times its volume of 15, which is 18, and the mass of the water is the density of 1 times the volume of 250, which is 250. So my overall mass, when I add these two together, is 268 grams. So my overall density is my overall mass of 268 divided my overall volume of 265, which is 1.0113 dot dot dot, which is 1.01 to 2 decimal places. Question 12. So looking at a liquid B first of all, density of B is the mass of B over the volume of B, and I'm told that the mass of B is 1.1 gram for 1.1 centimeter cube volume. So my density of B is 1.1 divided by 1, which is obviously 1.1. Now my density of A is, we're told the densities are in the ratio of 19 to 22. So if the volume of my B is 1.1, my density of A is going to be 19 over 22's worth of the 1.1, which is 0.95. So my density of A is 0.5, density of B is 1.1. Now density equals mass over volume. Multiplying by volume, we get mass equaling density times volume. So I can now work out my masses. So the mass of A, which I have, is 0.5 volume. Question 13. So Mary is wrong. Why is Mary wrong? Well, she's got the wrong base angles. She's right to say that the base angles of isosceles triangles are equal, but the base angles are these angles here at A and B. So she's got the wrong base angles. Now for part B, where's she gone wrong? Where's William gone wrong rather with these workings? Well, it's the reason is given for the first angle. Angle EGH is indeed 57 degrees, but that's because alternate angles are equal, not because of corresponding angles being equal. Question 14. So first thing I've done is to say angle BEF, this angle here, is 133 degrees. And I've worked that out because angles on a straight line add up to 180 degrees. And then secondly, I've said that X is 133 degrees because alternate angles are equal. This angle here is the same as this angle here. So X is 133 degrees. Question 15. We have two regular pentagons here, which are 5-sided. Now exterior angles always add up to 360 degrees for regular shapes, so each exterior angle is going to be 360 divided by 5, which is 72, and therefore each interior angle is going to be 108, because interior plus exterior equals 180. So each interior angle of these is 108. So this is 108, this is 108. Now angles about a point add up to 360, so X must be 360, take away 2 lots of 108, which is 144 degrees. Question 16. Now you've got to be careful here because it emphasises the need for you to give a reason for each stage of your working. So each step must include a reason. So I've started off with this angle here, it's angle EAB, and I've said that that's 54 degrees because alternate angles are equal. So this is 54, this is also 54. So the Z angle rule, alternate angles are equal. Now once I've established this, I've then moved on to the blue one, and because that's 70, the angle AEB must also be 70 degrees because vertically opposite angles are equal. Remember to use the word vertically. Having worked out the 54 and the 70, this must be 56 degrees, and the reason for that is angles in a triangle add up to 180 degrees. And having established that this is 56, x must be 124 because angles on a straight line add up to 180 degrees. So 4 angles worked out, 4 reasons given. Question 17. This is a regular 9-sided polygon. Exterior angles always add up to 360. So each of the exterior angles, given its 9-sided shape, must be 360 divided by 9, which is 40. And if the exterior angle is 40, the interior angle must be 180 take away 40, which is 140. So all of these interior angles are going to be 140, including the one here and here. Now, this shape EBCDE is a 4-sided shape. It's a quadrilateral. So its angles must add up to 360. Now, it's symmetrical, so these two angles here must both be the same. I'm going to call them y. So y plus 140 plus 140 must all add up to 360. So y must be 40 degrees. Now, given that this little angle here is 40 degrees, and the whole angle right round there is another one of the interior angles of the shape, being 140. So what I've called x, the angle BEF, x, must be 140, take away the 40, which is 100 degrees. Question 18. This is a regular pentagon, a regular 5-sided shape. Exterior angles add up to 360. It's a 5-sided shape, so each exterior angle must be 360 divided by 5, which is 72. So the interior angles must be 108. And therefore these two angles that I've called x must be 72. In fact, thinking about it, that's really what I had right back at the beginning. I could have just said that is an exterior angle and made those 72 straight away. So anyway, those two angles there are 72. Now, triangle CFD is an isosceles triangle with base angles being equal, the base angles being 72. So angle CFD must be 180, take away the two lots of 72, giving me 36 degrees. Question 19. Now, a 10-sided polygon is called a decagon, if I can say it. It's a regular shape, so I'm going to call it a regular decagon. Now, one of the interior angles is 144, so work out the sum of the interior angles. Well, it's got 10 of them, so 10 lots of 144 is 1,440. Question 20. So another one where we must really focus on giving clear reasons. So each angle we work out, we need a sentence. So let's start off with this angle here, angle ACB. That's 45 degrees because angles in a straight line add up to 180. I've then moved on to this pink angle and said angle ABC must be 65 degrees because angles in a triangle total 180. And once I know that's 65, x must be 115, being 180 take away 65, because angles on a straight line total 180 degrees. Question 21. So angle ABQ, A to B to Q, must be 55 degrees because angles in a triangle add up to 180 degrees. Now, once we know that, we can say x equals 55 degrees because alternate angles are equal. Is the z angle rule again. So x equals 55 degrees because alternate angles are equal. Question 22. So angle DBC, this angle here, is 38 degrees because alternate angles are equal. It's the z angle rule again, so just sort of see that z that I've highlighted there in yellow. So DBC equals 38. Now, once we know that, this angle here in red, angle BCE, must be 101 degrees because angles in a triangle total 180 degrees. Now, this is a parallelogram, so this big angle here, the complete angle that I've marked in black, angle DCB, that must be 120 degrees because opposite angles in a parallelogram are equal. Now if that whole angle is 120, with this part here being 101, then x must be the difference. So x is 120, take away 101, which is 19 degrees.